basically the deep diving of the demand planning. So first we'll get into the details of the theory part, what exactly is meant by demand planning, what are the different key aspects of the demand planning, how the forecasting takes place, how the statistical forecasting takes place, what is the XYZ ABC analysis, so on and so forth. So okay, so moving ahead, the agenda for, and because demand planning, this particular module number 6, will be starting, and we'll try to finish it by in the interest of time. If at all you guys have any issues or any doubts, then you can always reach out to me through the LMS link, or whatever you have doubts, you can post it on the links. So in the subsequent sessions, we'll try to resolve those. Okay, so in agenda we have demand planning process, a high level process. How does the demand planning process works in the framework of IBP? Then we have a supply chain network, which basically takes the input from the output of the demand planning process. Master data requirement, this is one of the most important and key factor of the IBP process. What is meant by the transactional data, and what are the requirements of transactional data? Then creating the first demand planning view in the planning worksheet, we'll see what are the different aspects and what are the different attributes and key figures for the demand planning view. So we'll try and set this in the Excel user interface as well as in the web interface. Key figures for demand planning. What are the key figures for demand planning? I think some of the participants like Sharna and Weber, they are already now aware about some of the key figures related to the planning function. So we'll have a little bit of a further deep dive in the demand planning view. ABC XYZ classification. This is also an important aspect of the overall demand planning process, because it gives us the segmentation. So we'll see how does actually ABC XYZ classification works in our day-to-day scenario, and how does it help us to identify what sort of strategies are required to be, appointed for your planning process. Outlier correction, this is also one of the important aspect. As we get into this, we'll try and understand what does an outlier mean and what sort of corrections are required for the outlier. Then the most important piece of this particular section is the statistical forecasting, because this is an extremely important topic, to understand how the statistical forecast is generated by the SAP IBP process. On the right hand side, we also see some of the other aspects like NPI, new product introduction, then consolidation of demand plan, and overall release of demand and supply plan. So these are the broad level topics we'll cover as a part of theory, as well as some of the points we'll try and actually do a little bit of a hands-on in the system. So any specific doubts or any topics you feel are missing in the curriculum which you want to add, something like that? So move on to the major aspect of demand planning process. Firstly, to understand how the demand planning process works, it's extremely important to understand what exactly is the forecast, and how does forecast operates, what are the types of the forecasting. So that's the reason I've added these additional notes in the curriculum, so that we get into the details of how does the forecasting process works, because it's very important for a demand planner or a planner to understand what are the different aspects of the forecasting. And if he understands the forecasting process, I think rest of the activities he or she can do very easily. So basically, in a broader nutshell, there are two major types of forecasting methods. Okay, one is called as a qualitative forecast, and another is called as a quantitative method. So what does a qualitative and quantitative method means? Okay, in qualitative methods, the forecast is majorly done through a judgment or an opinion or an emotion. So this is basically it can be a judgment of the top management team, that the top leaders in the organization, they may feel that for a particular product, the forecast will be, let's say, 10,000 pounds or 10,000 pounds of a product. So this is basically a judgmental view taken by the top management, considering the market requirements, considering the market dynamics. So these kind of forecasting process are called as a qualitative method, wherein it's purely based on the opinion of a person, of a single person or group of the person, mainly from the top management team. And then they tell the people or people in the downstream, like planners, that okay guys, you plan for so and so product. So in scenario or in industry, the qualitative forecasting is not majorly used. Earlier, it used to be very frequently used by the top management, and they used to have a top-down approach, wherein the forecast was given by the top management to the teams down the line, and the production was happening, based on these numbers. But the other part of the forecasting, which is more of a scientific method, is called as a qualitative method. So in qualitative method, the forecasting is done based on the mathematical models. They are objectives in nature, and they really rely on the computation. So there is a concrete set of history, which is considered, and the mathematical models which are designed by the statisticians, they are applied on the historical data, and then they identify, the forecast, or they define the forecast for the future. So very frequently, most of the organization in the current scenario are often adopting, the quantitative method of forecasting. So now we'll just have a deep dive of to understand what are the different types of forecasting in the qualitative and quantitative method. Okay. So in qualitative method is further divided into executive opinion, okay, what I just mentioned about the market survey, Salesforce composite, and Delphi's method. Okay, so these are the main four methods which are part of a qualitative forecasting process. So in executive method, you see, approach in this method is basically a group of manager meet and collectively develop a forecast. Okay, the group of people may be from the sales and marketing team, and sometimes from also the product management team. They may decide that based on the market scenario, based on the typical behavior of the market, they may say that the forecast will somewhere be in this particular range, and they will define the forecast. Having said this, when I said that most of the time the quantitative methods are used over qualitative methods, but it does not mean that always the quantitative methods give the best results. Let's take an example of the period, just a pre-period before we were badly hit by the COVID. All the businesses were working extremely fine. They were following the proper forecast. And just, I would say, just a couple of days before the COVID struck the entire world, there was a pure set of forecasts for most of the organization, having, the visibility of next 2 to 3 years, wherein the quantitative method has delivered, the forecast based on the statistical opinions. Okay, but when COVID struck, entire market collapsed, entire economy for the entire world has collapsed, and everything went into bad shape, right? So during the COVID time, in the pre-COVID time, now let's assume the pre-COVID time. Okay, in the pre-COVID time, the management could not finalize, what could be the forecast for next 3 to 4 months, because they didn't know how long the situation of COVID will last. Okay, so in such scenario, it is extremely important for the management to take judgmental call. Okay, so now for such scenario, most of the organization has taken the judgmental call that because COVID has hit the entire nation or the entire world extremely bad, in very badly. So they started protecting the inventory. They started reducing the inventory, reducing the demand, reducing the production, because somewhere down the line they felt that the market is collapsing, so the requirements will definitely go down. So this was a judgmental call, which is part of the qualitative method. Okay, so in some case where we do not have a proper historical data to prove the future requirements, at that time the qualitative method is also applied in scenario. Okay, then the next method is basically market survey, wherein this basically talks about an approach wherein people are interviewed, or the end customers are interviewed to identify the demand. This typically happens for a new product. Okay. For example, let's say when the mobile phones were introduced, or when mobile phones were first came into the market, then when it was launched in the market, people had taken the reviews of the mobile phones, and every time we have this new technology coming in, there are something called as a market survey, which is taking place, which actually gives us the information as to how the market is behaving. So based on that, the information is collated, and this collective set of information is helping the organization to predict the future requirement for such products. So this is how the market surveys helps to identify the forecast. The next one is Salesforce composite. Okay, so this is basically followed in most of the organization, because every single customer in most of the organization is assigned to a single salesperson. Okay, so for example, there is one salesperson who's handling 10 different customers. So this salesperson is always in touch with these customers, and he's always trying to discuss with them about what's happening in their organization. And based on this, he gets the input from the customer as to what could be, the forecast for his product for future. So this, in typical world or in technical term, this is called as a sales force input. So sales force input is basically the input that is received by a salesperson of the organization from his customer. Okay, so this is extremely important, because Salesforce input is, very, very important to define the forecast in the later stage, because this is the actual customer requirement. It more or less it is based on, the point of sale data. The last one is in the qualitative method is Delphi's method. Okay. And now Delphi's method talks about an approach in which a consensus agreement is reached amongst a group of experts. Okay. And Delphi's method is even widely used in the SAP IBP or in SAP APO demand planning tool. Okay. When we say terminology called as consensus forecast, that means in current scenario, okay, the consensus forecast means a demand planner who's part of the supply chain organization is discussing or is challenging the forecast with the commercial organization, with the sales team. And in the end of their discussion, both sales team as well as demand planner, who's part of supply chain team, they meet at the consensus and they identify the final forecast. So at the end of the process, both sales team as well as supply chain team are in agreement to a particular number for a particular product as a forecast for its future. So I think this is also widely used in scenario. So in a nutshell, this is how the qualitative forecasting method basically works in scenario. So before we move on to the next methods, so now we move on to the most scientific method, or I would say a mathematical method called as a quantitative method. Okay. Now in quantitative method, basically there are two main aspects or two main pillars of the quantitative method. One is time series model, and another one is associative model or associated models. Okay. So basically time series model looks at the past history, the historical data, and they analyze the historical data in various methods and try to populate the forecasts for future. Okay. So for example, time series method in itself would have, let's say, a moving average, or let's say a very first is basically a simple average. So if a particular product we are selling, let's say 200 pounds every month, okay, like for example, if we are in the month of August, then in July we sold 200, in June we sold 200, and also in May we sold 200. So the simple average of this particular product is 200 pounds of forecast. So simple average will give basically 200 pounds of this particular material as a forecast for future month. Similarly, if we talk about 3 months simple average or 3 months moving average, it basically talks about shifting the months. For example, now for the same set of an example, if we say that for the month of April, for the month of May, June, and July, we sold 200, 200, 200. Okay. So the forecast for the month of August would also be 200. Now, when we try to identify or work out the forecast for the month of September, we will consider August, July, and June, because we are talking about a moving average. So the average of the forecast months are also moving along with, the months that we are moving in. Okay. So that's why it is called as moving average. Okay, so there are a lot of methods in this which we'll try to see when we actually get into the system, and we'll try and understand, how system actually uses its intelligence to work out in the background, the forecast for future based on the historical data. Okay, now we move on to the next level of forecasting, which is called as a associative models. So this basically talks about one forecast being dependent on, the other variable, or it is associated with the other variable. Okay. For example, let's say a demand of a mobile phone. Okay. Or for example, a demand of a battery of a mobile phone is dependent on the demand of the mobile phone. Okay. So for example, if the battery is manufactured by somebody else, okay, and if the mobile phone manufacturer is a different organization, then the person who's manufacturing the batteries for the mobile phone is always dependent on, the sale of the mobile phone, which is basically done by some other organization. So associative method always talk about forecast related to other variable. Okay. So it can be anything, like for example, a pencil and an eraser. So these are basically associated with each other. So something which is used as a complement or as a pair is basically considered as an associative demand. Okay, so I'll just go down a little bit just at the high level. Okay, we don't need to try and mug up the definitions for all this, but at a broader level concept, we need to understand how these particular forecasting models work. Okay, because system has everything already fed in as a part of master data. So we just need to understand, how this functionality works. We don't need to know what are the background statistics behind this, what are the different formulas on which, this particular model works. It's all already taken care by the system. But it's important for a planner to understand, the high level definition and the very high level concept of what are the different types of forecasting and how it is used. So, for example, simple mean is basically average of all past data as a forecast. It's as simple as that. It's basically an average. Moving average, as I said, is basically moving every time. Then we have weighted moving average. So weighted moving average basically uses an average of a specified number of the most recent observations. Okay, with each observation receiving a different emphasis or a weight. So basically, most recent data gets a maximum weight, and less recent data will get a little less weight. So that is called as a weighted average method. So what it means is, for example, if you are considering a span of, let's say, one year horizon, which is basically 12 months or 52 weeks in total, if you are basically planning based on your weekly cycles, then 52 weeks is a relatively bigger span of horizon, okay, for which you consider your statistical data. Then in this case, if you apply a model called as weighted moving average, then system will automatically consider, the last 3 months, for example, as the highest weight. Okay, because this is a recent history versus the first 3 months. That is, for example, if you are talking about, if you are in the month of December, let's say December 2023, and you want to identify or define the forecast for the year 2024, then being in December 2023, system will consider October, November, December, that is last quarter of 2023, as the highest weight for calculate the moving average vis-a-vis, the first quarter of 2023. So these weights are basically defined in the part of calculation by the system, and you always have a possibility of changing this master data based on, your understanding of the business and your understanding of the product. Okay, similarly, exponential smoothing. Okay, so what it does is, it tries to smoothen the data. It is basically a weighted average procedure with weights declining exponentially as the data becomes older. Okay, so similar to weighted moving average, this also works in the similar fashion, but it rather tries to, smoothen the data. For example, weighted moving average will consider 3 months bucket, but this will consider everyday bucket, and slowly it will reduce the weight of the data for calculating, the future requirement. So in terms of result, okay, now one would have a question now, which is the best method, which will feed your organization. So there is no best method at all available in any of this model. Okay, it depends on the behavior of the product. Okay, so for example, if you're talking about, let's say, in let's keep it simple. If you're talking about 10 products of the organization, you consider the set of data for the 10 products, then each of these 10 products would have a different behavior in your organization. Okay, so some of these products would be best suited for a simple moving average forecasting process because they are extremely stable. Okay, and others may also have, may also not be in a position to give the best forecast even with the exponential smoothing or with trend projection or with seasonality index, because it depends on the product variability and product behavior and market behavior. So just keep this in mind that there is no best process available for any of the, model which which will always suit the product behavior. So if for a product, let's say mobile phone, okay, if you have just launched the product and it is now in the peak season, okay, so it is new technology introduced to the market. Okay, so you will get that you are getting more orders every month. Okay, in the first month you grab, let's say, 100 mobile sets of order. In the second month you will get 200. Third month you will get 300. So in third month, if you try to apply the model, I think then the trend projection model will work well in the third model, because it will see that last 2 months there has been an increasing trend of sale of the mobile phones. Okay, however, after 6 months time, when technology is older, there is a new technology introduced in the market, then this trend line will not work, because this historical data will show that for last 4 months it has been growing well. But having said this, it will not work, because that there is a new technology introduced in the market. So you have to apply maybe for 1 month. For the seventh month, your forecast may go wrong. But from the eighth month onwards, there will be correction in the model, wherein system will consider weighted moving average. It will consider overall sale of mobile for last 8 months and then divide it by 8. And instead of increasing forecast, it will start declining the forecast. Okay, and 9 months onwards, you will see that your forecast for this particular set of mobile phones or the model of mobile phone is actually declining, because the new technology is introduced in the market, and now this mobile phone is more or less an outdated mobile phone. Okay, so these all kind of modeling is basically done in SAP IBP process. It is quite efficiently done, but having said this, you will not get the forecast accuracy as 100%, because by definition, when I was demand planner in the organization, I used to tell my management that I am the only person in the organization who's paid for making errors, because every entire organization has accepted that forecast can never be accurate, and there will be always an error in making the forecast. So it is widely accepted that the forecast will never be accurate. However, it is job of the organization and the responsible person, like demand planner, like sales team, marketing team, to work together under the umbrella of integrated business planning process and try to reduce the error so that the accuracy is improved day by day. Okay, so the next one is basically trend projection, which we just talked about. It talks about the trend. Okay, it identifies that the future pattern is not like a moving average. It's not a simple moving average. It's not exponential smoothing, but it's showing the trend. So system will apply a model called trend, and it will give you the future forecast, which is incremental than your past forecast. Okay. The last one is basically seasonal index. This is used for seasonal products only. Okay. For example, there are certain fruits which are available in a particular season. Like for example, since I'm in India, so the one of the best seasonal fruit in India is basically mangoes, which are exported all over the world. So these mangoes are only available from the month of March or from the month of February till June or July. Okay, so these are the 4 months when the mangoes are available. So if a planner is identifying the demand for mangoes, then he has to apply seasonality factor. Or in short, when IBP is trying to identify the demand for the mangoes, it will check that the historical trend is in such a way that
Hey, ZaranTech now offers SAP corporate training? That's right. Train your workforce in SAP with our comprehensive program. We offer customized courses, certified trainers, and hands-on labs for both individuals and businesses. Our standout features? Bespoke training, fully configured servers for practice, in-house materials, and a dedicated LMS. Plus, get session recordings and 24/7 support. From functional to technical modules, we have got it all. Choose ZaranTech for SAP training and watch your team excel. Learn, upskill, succeed with ZaranTech.
there is a demand for this product only in the month of February till the month of June or July. And after that, the demand is getting lower, and it becomes almost zero. So these products comes as a part of seasonality. Like for example, umbrella, the jackets, winter jackets, these are the products which are called as seasonal products, which are only having demand in a particular season. So system will automatically identify, the behavior of these products, and it will apply the best fit model. Okay. So these are basically, the various methods by which forecasting can be defined. And all these methods are part of something called as an algorithm in the SAP IBP. So SAP IBP has, or even SAP, normal SAP, which is having a forecasting tool, or an APO, advanced planning and optimizer forecasting tool. All these tools has something called as an algorithm. So in this algorithm, all the master data is fed, and basically we just have to select, the kind of algorithm that we want to apply, and then it will apply the specific algorithm, and give you the results. So we'll see how it works actually when we get into the details of this statistical forecast, either or any specific questions. So these are basically some of the graphs of how the time series forecast looks like. Okay. So if you see a trend, the trend component looks like this, like it's trending upward, or it is, when it is trending downward, it will be like downward kind of a trend. You see a seasonal component. Okay, in the seasonality, when there is no season, the demand is dropping, and when there is a season, demand is at peak. So seasonality component will look like something like this. You can see year one, year two, year three. This is basically the time frame. So in all these graphs, on the x-axis you see the time, and on the y-axis you see the demand. Okay, this is random components in the historical demand. So this is normally how the actual sales look like. And based on this kind of erratic sale, a planner has to identify the forecast, which should not be as noisy as this. All these peaks and downs are basically called as noise in the forecast, or it is called as noise in the graph. So basically, planner has to apply the best fit model and try and reduce these peaks and these downfalls, and try and have something forecast which is somewhere in the range of this, something like this. Now we go back to the presentation of how the demand planning process works in the SAP IBP. So this is a block diagram of how it works. Okay, there are certain parallel process takes place. Some of these in the forecasting model or in the demand planning process. Some of these activities are done in the SAP web user interface, and rest of these are done in the Excel user interface. Okay. So when we go into the practical, examples, when we try and run these particular scenarios in the system, we will try to understand as to what all things we need to work in the web interface and what all things are executed in the Excel interface. Okay. So first starts from here. Okay. Which is basically upload historical sales data. Okay. Now, why upload historical sales data? Because your IBP may not be the only tool. Okay, because some of the organizations use various different tools like ERPs. Okay, they have an SAP tool which is called as ERP tool. In ERP tool, they will have SD module, which is sales and distribution module. Okay, so from this ERP tool, they have to upload the data in the IBP tool. Okay, and this happens almost every day. Okay, so this exchange of information, in the best case, it happens every hour or every minute if it is a live system connection. If it is done through a batch job, then every night. Okay, if it's in America, then every night US time, in the midnight or somewhere at 2 o'clock or 3 o'clock early morning, the historical data is uploaded from ERP system into IBP. Okay. So this leads to a question for me. By any chance, do you know when the historical data is loaded, or you have all the historical data in your IBP all the time? Because for your invoicing, are you using the IBP to generate the invoice to the customers? I believe no.
No, that's done within SAP HANA.
Okay, so you use SAP HANA.
I
Okay.
believe historicals are in there, but I don't know if any of the demand planners want to correct me if I'm wrong.
If you're using SAP S4 HANA, so it will be always available. It's a live system. If you are using SAP ECC or some other module of SAP, then you have to, communicate or integrate the data in the IBP. But according to you, I think your IBP is always updated with the historical data, right? In the live system.
Yes, I believe so.
Okay. So this takes care of this particular block of upload historical data. So this is the first process. Okay. And this process is done automatically, either through a user interface which communicates between the two systems, or it is uploaded as a batch job, okay, in the background, not done by anybody else. Okay. Then after historical data is updated or uploaded, you have a sales data available in the system. Then you have to do the pre-preparation work for forecasting. So now we are talking about statistical forecast or working on the forecasting models. So as a part of pre-preparation work, okay, these are basically optional steps. Even if you don't run this step, it is fine. Okay, only thing, it will not do the forecast correction or the sales history correction. So some of the examples of pre-preparation steps for forecasting are something called as outlier correction. Okay. Now, what is outlier? Outlier is basically an unforeseen event, okay, which was not projected. Okay, for example, if you are selling a product, okay, which is, let's say, 1,000 pounds, or somewhere, sometimes it is 800, sometimes it is 900. So it is in the range, your historical sales is in the range of 800 pounds to 1,000 pounds for a particular product. So now this product, every month, it is having some kind of a behavior wherein it is sold to the extent of 800, sometimes 900, sometimes 850, sometimes 1,000. So it's in the range of 800 to 1,000 pounds on a month-to-month basis, and it is working quite well. So on a particular month, let's say in the month of August, there was some promotional activity done by marketing team wherein, the forecast for this product has increased, or the demand for this product has increased from the maximum of 1,000 pounds to, let's say, 3,000 pounds. Okay. So there was a big order received by the organization on the account of some activities done in the background by marketing team, let's say some promotional activity, or they offered some kind of discounts in the process, which has inflated the demand from 1,000 to 3,000. So company has received the order for 3,000 pounds, and they changed their production plan. They made the products available, and finally the products were shipped. So now in the subsequent month, that is in the month of September, when a demand planner is identifying or trying to work out the statistical forecasts for this product for the month of October, November, December, Jan, Feb, for the next 6 months, he will see that the historical data for this particular product or historical sale for this particular product was in the range of 800 to 1,000 pounds. However, in the month of August, there was a demand of 3,000. So this is not the normal case. So this particular scenario is called as outlier, okay? Wherein, the demand was basically inflated because of some external factors. It can also happen that instead of 1,000 pounds for that particular month, the company has sold only 200 pounds. So it was a negative sale. So it was a negative outlier. So this particular behavior of a product will impact the statistical forecast if we do not adjust the sales history. That's the reason you have a process which is called as sales history adjusted. So what planner does is he looks at the historical data and he gets the feeling that this particular product has an average of 800 to 1,000 pounds of a sale, but in a particular month the sale has increased or it has reduced. So he will consider this as an outlier and he will chop it off. He will not consider this data of 3,000 or 200 for future requirements. So he will do that correction. So that is part of the pre-preparation step, wherein the forecast is basically, the sales history is basically corrected so that future forecast is more or less accurate, or it improves the accuracy. Now, some of the pre-preparation steps are basically outlier correction, then assigning planning object XYZ segmentation. Okay, pre-preparation step can also be ABC classification. Okay, so that you have the weightage of what products to be given, what kind of a forecast. So that we'll see when we get actually into the system. Okay, so these are basically the definitions for the pre-preparations work. So once the pre-preparation work is done in the system, then we have to finalize the forecast model. Okay, which forecast model do we want to apply to the process so that system gives us best results? Okay, so for this, basically there are three main steps which are followed. One is pre-processing steps, data cleansing. Okay, that means outlier correction. Then forecasting step, algorithms. This is the step where you have to finalize the algorithm in the system. And post-processing step. Last one is the post-processing step, which is basically the execution step. So this particular window, all these steps are basically executed in the web interface. Okay, not in the Excel file. The outcome of this is basically you assign a forecast model to planning object. Okay, and then you see here a tab called Run Statistical Forecasting. So this execution of forecasting you can done in the Excel interface as well as in the web interface. So we'll try to create these forecasting steps in the web interface and then run the statistical forecasting in the Excel and see the output, how it actually works. Once the statistical forecast is run, then we see the forecast results. Okay, and there are some optional steps. If you want, you can get into the details of why system has adopted this particular model and not the other model. Okay, so you will get a clear set of information from Excel or from IBP, which will give you the idea of how system has arrived to this particular forecast, and how system has generated the forecast and why it was considering this method only. So it will give you clear identification why system has selected this as a set of forecast, and it will also give you the projected forecast accuracy, which will help you to understand where you will be in future with respect to your accuracy. Then finally, upload forecast to the external system. Okay, if you are using the forecast as an input to your supply planning process, then you have to upload this forecast into external system or use forecast for other IBP process. So this is a general process. wherein forecast is used as a input for the next processes in the IBP. So any specific questions for this particular slide? No?
No questions.
Okay. So we move on to the next slides. This is basically what I just explained. So I'm not going to get into the details. Like the process steps are create or edit forecast model, then assign forecast model to planning object, gather historical data, create assignments for new product introduction if it is a new product, then integrate promotions, okay, assign planning objects A, B, C, X, Y, Z. This is optional and this is part of preparation. Then run time series analysis and change point of detection, run statistical forecast, compare, and then upload. So in supply chain network, okay, as we have seen, the IBP diagram wherein you see IBP for sales and operation planning, then inventory, then response and supply, and demand driven replenishment. So DDMRP. So all these points we have already covered in the previous sections. Okay. So we move on to the other slide, which is basically supply chain network. So what are the factors which are part of a supply chain network or which forms, the end-to-end supply chain management? So at a high level, under the umbrella of supply chain network, we have supplier who are providing us the raw materials or component for production. These we call as a supplier or vendors. Then we have manufacturers, either if the products are manufactured in-house, then we are the manufacturer of that product. If the products are manufactured in third party, then we have third party manufacturer or we have tollers. So these are all part of the supply chain network diagram. Then we have distributors, okay, who distributes our product down the line to the stockist or to the retailers or to end customers. So they are basically taking care of distribution network. Then we have retailers who are basically selling the products to the end customer. So from for the end-to-end gamut of supply chain, we have suppliers, manufacturer, distributors, and retailers, which forms the chain of supply chain management. Some of the key requirements, okay, after we understand the supply chain network and who are all elements of the supply chain, the basic important factors of the system is master data requirement. So this is the point where most of the organizations struggle, to set the master data, because master data in the ERP or in the IBP system is a huge task, and it is extremely important for any organization to have a good amount of master data or an accurate master data, because master data is the input, or it's basically the brain of the ERP tool, which basically process the data and gives you the output. If there is an issue in the master data, if you don't understand what the master data is for, and if you have incorrect master data in the system, then all your processes will go for a toss. And the main categories of master data are basically product master data, wherein we saw product codes description, product ID, product description, so on and so forth. Then we have customer master data. Okay, product master data is also called as material master data. Customer master data, you have customer information, including their names, contact number, address, their tax registration number, so on and so forth. Then you have location master data, like each and every location, whether it is manufacturing plant or whether it is a depot or it is a warehouse or it is a stock point, all these should be mapped in the system under location master data. So you may have inventory at various stage, and whichever stage you want to track your inventory, you have to map it in the location master data. Then next one is basically the time master data, wherein the information related to time, such as calendars, the holidays, because it's also important to update your SAP IBP calendar with the holiday. Otherwise, system tends to give commitment to the customer that the delivery will be done on an holiday, which is a national holiday or a holiday for a specific country. Okay. So you have to update. There is a provision in the system wherein you can update the holiday list in your calendar in the tool, so that when there is a customer order, system will not give the delivery date on that particular holiday because nobody is in the office. Okay, so these are basically the key attributes or the for the master data. Like for example, it is important to understand, what are these attributes are. So these are basically driving the IBP process. So for customer, we'll have cust ID and cust group. Okay, these are the two main attributes, and these are also dependent, or it will also be designed based on your requirement. So it may happen that you may have some different name as well, or you may have something else as an attribute. For location, you have normally lock ID, location ID, then product, you have product ID, so and so forth. So all these are basically the examples of attributes wherein you see customer, location, product, source, customer. These are the combination of attributes, source, customer, group. So that you have functionality of merging 3 to 4 attributes all together. The next one is transactional data requirement. Okay, one of the first one that we saw is basically a master data, wherein system is updated with the master data functionality, and you don't need to review master data every day. Okay, but having said this, you have to review master data after a periodic interval. That periodic interval will vary based on the type of master data. For example, let's say a product master data. Okay, you don't need to review the name of the product, okay, the code of the product every month or every 6 months or even for an year, because once you set the name of the product and the product ID, it will remain sacrosanct for that product for the ages. But the lead time of the product may vary. Okay, if some products you are manufacturing lead time is, let's say, 2 weeks time, then in certain scenario, because of some capacity constraint, the lead time may increase to 3 weeks. Okay, similarly, the batch size of the product, if currently your batch size is, let's say, 100 pound or let's say 1000 pound, in future it can increase based on the capacity expansion to 3000 pound. So whenever this kind of changes takes place in your manufacturing organization or in your supply chain organization, you have to go back and update your master data. So that's the reason you have to have a certain periodic periodic timetable defined for updation of the master data. Similarly, the transactional data is something that we do on a daily basis or at a frequent intervals. For example, sales order, as and when you receive the sales order from the customer, you would enter the sales order in the system. So this is called as the transactional data. Deliveries, invoicing, stock levels, promotion, marketing data. So these are all transactional data, which is every day updated in the system as a part of transaction. Now we'll move on to the next point, which is basically creating first demand planning view. I think three of you has already created, the planning views, so they are aware about that. I don't know about the rest of the people and what exactly is their role in the SAP. So when we get into the SAP, so just let me know if you want a little bit of a brush up of that. I will quickly, get into that and try and explain to the people. So defining the planning view, first you have to define the planning area. I think planning area is defined for all of us in the test system. So all of us will use the same planning area. We'll configure the key figures. We'll define the planning levels, configure planning operators, and set up planning book data views. Okay, so first you may have to log into the web user interface. Are you all logged into web user interface? Okay, so I'll start in the user. We are talking about the statistical forecasting model. So we'll try to create one model in the web interface and try and run it in the Excel user interface. So ideally, the general process which is followed for the statistical forecast is you have to create the forecasting model, okay, the statistical forecast model in the web user interface, and then you save it in the web user interface, and then this forecast model is available in the Excel user interface, and you just need to execute that. Okay, so you just need to open the web user interface, and we'll go to that. Similarly, you also open the Excel user interface and try and create these key figures. Okay. So would you like to share your screen so that I understand, where exactly you are?
Could you repeat, please, how you did that? I'm sorry.
Oh, okay. Okay, now you first open
Thank you.
both your user interface, web as well as Excel. So first you go to the Excel user interface because we have to design a report which will be executed for the part of statistical forecasting. Okay. So you can, if you have a ready-made report, you can go to edit view, or you have to create new report, you have to go to new view. So I think for part of this training since last couple of weeks, they have some reports already ready in the test scenario. Okay, guys, and please log in only to the test system. I forgot to mention that, but I repeat, this training is only to be executed in the test scenario, not in the live system. So please do not log into the live system. Otherwise, we will end up messing up some of the key data. So log into the test scenario, test system of web interface as well as Excel. So go to this edit. I'll show you. You will see the screen. Okay. In the time, you select the period. Okay. Time label as month. The next one is keep it rolling. And from you can consider January 2023 till December 2024. Are you with me?
Sorry. You said that we need to connect to test IBP,
Test.
right?
Yeah.
But how we can do that? I'm really sorry.
Okay, no problem. You see my screen?
Yes.
Do you see a button here? You will
Yeah.
see a log in here.
Yes.
Or else, can you share your screen, please, so that I'll stop sharing? And please share your screen. So I'll guide you.
Now you can see my text.
Yeah. Okay. You see the button log on.
Log on.
Yeah. Okay. Now you see. Okay. Do they have the access to the test systems as well?
Do we have me?
Everyone
no.
should. Yes, everyone should. But Victor,
I think.
I can send you something on the side for how to log in.
Okay. You can send it on the chat.
Okay. Now I have the steps. I will connect to test system.
Yeah. Okay.
Yeah. Thank you.
Okay. So are you aware of how to create the planning views?
Yes.
Okay. What we need to create is we need to basically create a statistical forecasting view. Okay. Report with statistical forecast. And then we run this report and see what is the output. Okay. So I went into the edit planning view of any report, which I'm trying to amend it now. So in the periods, I selected month rolling, and from Jan 23 to December 24, or this can be even longer. It does not make a difference. I would say August 25, for example, 2 years. Then in the attributes, for simplicity, I have only considered product ID. Okay, so you can select product ID in the attribute. In the key figures, okay, you have actuals quantity, then actuals quantity adjusted. Okay, so before we move on with this, I have one question for or Vaibhav. Where do you store your sales history? Is it actual quantity in your system, or it is delivered quantity? Because while I was working in this system, I found that some of the data are also in the delivered quantity. So when you invoice to the customer in SAP IBP, where does that quantity reflects? Is it getting loaded on actual quantity, and is getting loaded somewhere else? So any idea?
What sets ZaranTech apart in SAP corporate training? It's our unique blend of expertise and innovation. We offer customized courses tailored to each client's needs, ensuring relevant, targeted learning. Our vast trainer database brings you wisdom from the best in the field. Need resources? Access our extensive training material repository anytime. We are all about measurable results, providing detailed student metrics to track progress. And we don't just teach, we build community. Join our thriving social media network, connecting learners beyond boundaries. With ZaranTech, you are not just training, you are transforming your SAP expertise.
Or Weber?
For Canada, it is I use actuals quantity as a key figure.
Okay, and for US?
I've used actuals quantity as well.
Okay, then this is perfect. Okay, so in that case, your report should have a key figure as actuals quantity, actuals quantity adjusted, then statistical forecast quantity. Then I need baseline forecast quantity M1 as one of the attribute where we want to see the results of the statistic forecast, and baseline forecast quantity M2. And so make sure that at least these attributes or these key figures you have in the report. I repeat, actual quantity, actuals quantity adjusted, okay, because this will help you to identify the outlier correction. Then statistical forecast quantity, baseline forecast quantity M1, and baseline forecast quantity M2. Okay, so this should be part of your key figure. In the layout, you can put product ID and key figure in the row and time period in the column axis. Okay, for the layout, you can put product ID in the row, key figure in the row, and column axis in the, time period in the column axis. On filter, you can either have one of these product or you can have all of them. Okay, these are the same set of numbers provided by, I added one more 404464 because I found some good amount of data in this, because rest of these products does have good amount, but not the best data to calculate. So I click OK, and you see these kind of reports, right?
Yes. Well, I don't see the. I don't have information for statistical forecasting, but yes, I have.
Yeah, that's correct. Now just click on this run. I'm just checking. We don't need to run it now. We'll run it later, but I'm just checking whether you can see the forecasting models here. And just click on this run and click on statistical forecast. Okay, you will see this window. Are you able to see this window?
Yeah.
Okay. Now you have clicked, I have clicked here product ID. So you can click product ID and time intervals at month as month. And you see a tab here called forecast model to be used. So you can just click on that and see if you are able to see some kind of a forecast model. Like for example, I can see here, which I have created, Samir outlier correction, something like this. So are you able to see this?
Yeah.
Same one?
Yeah, I'm seeing the same one.
Okay, perfect. So you are also able to see the same one?
Yes.
Okay, perfect. So now we cancel this because we don't need to run it now. Okay, just cancel it. And now we set, the forecasting model. Okay, now we go to the web interface.
So sorry, did you click OK on that screen there?
No, I click cancel. Just click cancel.
Okay.
I just wanted to see whether you are able to see that model in your pop-up screen, because I created that very recently.
Actually, I don't.
Okay, got
I
it.
don't see that model in mine.
You don't see that? Have you selected only the product ID and the month? Okay, can you share your screen, please? So we'll just have a look
Oh,
at
I
it
see.
quickly.
I see it now. I had the wrong time.
Okay. Okay. Okay, perfect. So now go to your web interface, okay, and then you select, type here in the search box, manage forecast model. Okay, you click on manage forecast model. Okay, so you will come to this particular screen. Okay, now what you have to do is, first you have to select the planning area, and our planning area, as we know for the test, is ASRG prod. And select ASG prod and hit the button go. Okay, then you can scroll it down and you will find this model called outlier correction new. Okay, this is the one which I have created, and you can also create something like your own, but let's try and run this first and then you can create your own models. Okay, so click on Samir outlier correction new. And okay, one of, like, both of you guys, if you edit it, I'm not sure if that will allow. So you can click on the create, and Vaibhav, you can click on the edit. Okay, since you have said create, you have to give the model name. You can give your own model name, like outlier, something like that, and give the description to that model. That model will be in your name, wherein Vaibhav, you just need to edit it.
Yeah, got it.
So are you in this screen, Vaibhav? You can see the model name is Samir outlier correction, which is a non-editable field for you, correct? Because you have edited it. So you can only edit the settings. You cannot change the name, wherein for it will be, this field will be empty where she can change or she can give her own name. Okay. So now we are in the general screen. You can see 4 tabs on top. One is general, One is pre-processing, what we have just seen in the diagram, first diagram. Then we have forecasting step and post-forecasting step. Okay. So just if I go to the materials, okay. So these are the steps like preparation steps, then select the forecasting model, assign model. These are the steps that we are following now. And so I go back here. So now in the periodicity, you select month, okay, because we have created our Excel file based on the month. However, if you create this in the week, you can also run this model on week. So historical periods, I have considered 7 months because this is starting from January till July, January 2023 till July. So historical period is 7 months and forecast period can be 24 months. So if you have a big set of data, you can have historical period as 12 months. That means system will check last 12 months of history and whatever is the result that will be applicable to next 24. So for example, if you select here week, okay, then you have to put 52 weeks, which is 1 year, and 104 weeks, which is 2 years. So 1 year of historical data and 2 years of forecast period. So currently we are saying month, so we'll say 7, okay, and 24. Getting it? So all these are basically the optional field. So currently we'll not put anything here. Okay. So next step is pre-processing step. Okay. So these are the pre-processing step. And below that you see a substitute missing value. So now just click on this arrow. You will see this box. Okay. So now in this method, you have 3 options. One is mean, one is median, and one is given value. Okay. Do you understand what is mean and what is the median? Do you know what exactly is mean and median? Mean is basically average of total numbers. This is nothing but an average. Although in the technical terms, it has a different meaning, but mean is basically an average of total numbers. So for example, if your forecast total is 3, 5, 7, 3, 6, then the total of that is 24 divided by 5 number, that is 1, 2, 3, 4, 5, that is 24 by 5. So for this set of numbers, the mean is 4.8. Okay. So if you select the mean, okay, then if your set of number is this, it will divide it by 5 and it will give you 4.8. Median. What is median? Median is the middle number when the numbers are arranged in the order, in the order of by size. Okay, that is, or in the ascending order. For example, 3, 5, 7, 3, 6. If the same set of number, if we assemble or we arrange in the same order, then it will be, sorry, this is a mistake. 3 plus 3, then 5, then again 7, again 6 and 7. Okay, so in this case, the median will be 3, 3, 5. The median will be 5, not 7. I think there is a typo error in this because these numbers have to be arranged in the same order. Okay. So you understand that what is median, and mode is the most frequently occurring numbers. Like for example, in this set of number 3 is occurring twice. So it is occurring the most time. So mode is the same number which is occurring most of the time. Okay. So we go back. Okay. So we go back here. Now substitute missing value. Okay. And we are talking about pre-processing step. So what it does is, because our pre-processing step, we are considering the input data as the historical sale, okay, or actual quantity. See, input for the algorithm is actual quantity. Okay, so system will always analyze the data for actual quantity. Okay, and if actual quantity, if you click here missing value, if there is missing value in the actual quantity, for example, we are talking about, if we go here, we are talking about last 7 months of data. In last 7 months of data, that is from January 23 till July 23. So let's assume that in the month of March, there was 0 sale. So system will consider it as a missing quantity. Okay. So you have an option if there is 0 sale, because you have to do the data cleansing. This is part of data cleansing operation. Okay. You are cleaning the data. Okay. So in that case, if you put a mean, then system will put the average quantity as a forecast, as a replaceable value for 0. Okay. So for example, in the last 7 months of time horizon, if there are 3 instances, let's say in the month of February, in the month of April, and in the month of June, if there is 0 sale, then system will replace this by, if you select mean, it will replace it by mean value. If you select median, it will replace it by median value. So I have just considered 250 just to understand, how this system works. So I can give a value also. Like for example, if I feel for this particular product, okay, average I'm selling is 250. So I know the average sales number. So I will put a number 250 here. Okay. The input to the algorithm is basically actual quantity. That means it is going to analyze the actual quantity and save result in actual quantity adjusted. So all the results of this particular algorithm or this particular check or data cleansing or outlier correction will be saved in actual quantity adjusted. That is, in this report, this will be analyzed, okay, and it will be saved here. You're getting my point? And this will be the figure which will be used for statistical forecast calculation. If you enter given value, you can enter 500 if you want, okay, and put here actual quantity and actual quantity adjusted. Similarly, you can also put it whatever you want and you consider put here these two. Now we go to the forecasting step. Okay. Now here you have overall parameters. Okay. So main input for forecasting step, okay, should be actual quantity, correct? And target figure for forecast is statistical quantity. Or you can have here actual quantity adjusted because you're adjusting the sales history. So you can have actual quantity adjusted and the output will be stored, that is the statistical forecast result will be stored in the field called as statistical forecast quantity. Okay, so these are mandatory fields, so you have to fill this field. Okay, now the next column here, you see here a plus sign and you see next to that is algorithm. Okay, so you can click on this algorithm, you will see something like this. So since we are doing it for the first time, let's select the most simple algorithm, which is simple moving average. Okay, so that we can compare the data and see the results if they are correct or they are incorrect. Okay, so you first use algorithm, click first plus sign and put number of period as 3. So that will be 3 months because you have selected months in the general field. Okay, this is month in the general field. So this will apply 3 periods of month. Okay, and extend calculation for future period. That means it will keep on extending 3 months for the future forecast calculation. So you just tick on this. Okay, now this is the first algorithm and you want to compare the result of that. Okay, what is the result of that? So you put this as a baseline forecast M2 or you can have M1. You can have here M1. Okay, first one. Okay, now you again click on the plus sign. You will see again simple moving average. Select this only. And instead of period, you can put period as maybe 4 or 5 months. Okay, let's put 4 months. Click on extend calculation in future and put here baseline forecast M2. Okay, so second result you will see in M2. Baseline forecast quantity M2, you will see the second result. Okay, so these are the algorithm that you have selected. Since it's the first time, we are selecting the very, very basic algorithm. So when you practice, you can select all the algorithms together. You can select 10 algorithms and system will give you the output, different outputs of 10 algorithms. Okay, that we'll see when we get into the advanced stage. Okay,
Yeah.
Now the last section here, you can have a few more algorithms, but we'll keep it to this only because we have added only these 2 key figures to compare. Okay, if we want to see another, then we can have another M3, M4, M5. So you get all the results here. Okay, but currently we'll stick to only 2. Then you see here, utilize multiple forecast. Okay, so now here you have a tab, like you will get 2 results, 2 statistical forecast quantity, one in M1 and one in M2. If you select 5 algorithm, you will get 5 statistical forecast quantity. So now you want system to compare all these forecast quantity and give you the final forecast quantity as the best one, best chosen out of these. So for that, you click here, choose the best forecast. Okay. You also have the weighted average, calculate weighted average. When you click on the calculate weighted average, at that time, system will take the weighted average of all the forecast and give you as your final forecast, statistical forecast. Okay. But you don't want that because you want the best forecast. Okay. So you choose best forecast and measure used. And next to that, you'll see measure used for best comparison. So what is the measure that you want to use for best comparison? So you click here, mean absolute percentage error. Okay. That means all these forecasts, that is forecast M1 and forecast M2, you will get the results of that in the particular field. And then in the next step, system will compare the results of that. They will try to compare the accuracy of forecast or the forecasting error. And whichever M1 or M2, whichever is giving the less error, system will select that forecast and give you the final forecast. Okay. So you select mean absolute percentage error. Okay. Once you are done with this, then you go to post processing step. So here you have to select what all error measures you want to see as an output. Okay. So I clicked on mean absolute percentage error. So you can click on that. And if you want this to be reflected, then you see target key figure for MAP, and you have to select some of these tabs. Okay, but we have not added that tab in the report, but you can select model fit error MAP. We'll see if it is available. Okay, so once you do this, you simply save this. Did you save this?
Do I have to change because the number of periods in simple moving average 2 is 4? Do I have to change it to 5 before saving it, or?
Yeah, you save it to 4. Okay, you change
Okay.
it to 4 and see if it is saving. If there is no change, then it will not allow you to save. You have to, because you have clicked on edit, so you have to make some changes.
Right. So it just says forecast model updated on the bottom there.
That's done. That's done for you.
Okay.
Did you do it for yourself?
Yes.
And you have saved it as well?
Yes.
We go to the Excel and compare your results. We'll just see if it's working fine. Okay, so you have already saved it, right? Now you go to the Excel file. Are all the other participants on track? Okay, so this is your data, right? So you have started from April, is it? Or it was from January in your pre-planning book? Can you make it January 23? Yeah. And December 24. Okay, September is okay. That's okay. That's okay. Okay, now you go to run tab, click on the little corner in the run. Yeah. Go to statistical forecasting. Okay, now this is your executing. You have saved your data. Okay, you have created the model. Now you are executing. Click on statistical forecast. Yeah. Click OK. Okay. Now just click. Yeah. Okay. You see this outlier. Now wait. Click on this. Yeah. Select that model. Select that model. Yeah. Select. Yeah. Okay. And go to the filter on top. You see definitions. Next to that, you see filter. Yeah. Okay. You have selected all these products. Okay. Go back to definitions. Okay. Your target unit of measure in metric ton. Okay. That is fine with me. Now you click on the next. Okay. You don't need to, run. Okay. Navigate to status. Click on navigate to status. Okay. Your batch job is running. Okay. Just refresh that. Oh, I thought you used different name. Okay. Refresh. Let it show the, okay. You can see the log over above. Okay. Now close this. If you want, you can close this. Now refresh button. Refresh. Okay. Okay. I think the quantity adjusted you have put as 500. Is it correct? So for the first material, your actual sales is all blank. Okay. And if you remember the first tab where you did the outlier correction, there we said that if the sales history is missing, then replace it with 500. That's why you see all the actuals are replaced with 500 quantity from January until August, because you have given the period of 7 months, correct? In the first case, we had put that replace value with 500 if there is no sales history. And for the first product, that is 407393, you do not have sales history. So it has replaced 500 quantity, okay? Wherein for the third product, that is 407426, there is a sales of 479 metric ton, okay, in the month of Jan. The system has considered adjusted quantity as same. In the next month, Feb, you see 5748. So 5748 is there. In the month of March, you do not see any sale. So system has replaced it with 500 because that's what we had asked system to do. Okay. Now, in the baseline, okay, now the first case is not the good one because all your sales history is replaced by 500. So your forecast anyways is a moving average, so it will show only 500. So we cannot compare it. Now let's take the data for the material called as product called as 407246. Okay. Now in this, you see your M1 forecast is 1058. Okay, for the month of August. You are getting it? Okay, now this 1058, you try and take the average M1. M1 was 3 months, right? So 1058. Try and take the average of last 3 months. That is August, July. How much is it coming to? I can't see.
1331.
Okay, because we are already in August. So consider these three: May, June.
There we go. May, June, July.
1058.
1058. Yeah.
Okay, then June, July, and okay, forget about August. Let's say September, October, November, because August we are in the middle. So, take the average of September, October, and November. First one, yeah, M1. Is it 1333?
Yeah.
Okay. So because if you go back to your data sets, what you had mentioned is baseline forecast quantity M1 is moving average of last 3 months. And M2 was moving average for last 4 months. So if you take the total of September, October, November, and December, that will be your forecast for January in M2, correct?
Yep. 1149. Yep.
Okay. So in a nutshell, did you understand how this process actually works?
Yes.
Okay. Did you analyze in the meantime your sets of data? You can consider the last one if you want. Okay, 404464. I think this is the favorite product ID where I do a lot of experiment with, in the test system. So now you see your actuals are pretty stable, okay, for the last product. So your actuals quantity adjusted is all in line, okay. Only for the month of August, because it's the current month, system is not able to understand whether it is actual or it is current month. And we have given only 7 months. So if we have given 8 months, okay, we'll run this again. Okay, now I see that quantity adjusted, you have considered 400, 500. Okay. Now let's compare the results for M1 first. Okay, you try and select M1 555. That is September, October, November first. Is it 573? Okay. Then October, November, December, M1. Check M1.
That one was M1. M1 was
Yeah.
573. M2 is 546.
Yeah. M2, what was that? You might have given 4 months or 5 months horizon, right? So you have to add one more in the model.
544.
Yeah. So that's exactly the forecast for the next month. Okay. Now, so in short, system has two forecast line. Okay. Statistical forecast. One is in baseline forecast M1 and M2, and system is selecting only one out of that. Okay. Why it's selecting, M1 for certain cases, it may select M2 for other cases, okay? Because we have asked them to select the best one. So in this case, M1 is the best one because it is giving you less MAP. Okay, so how we see that? Now we understood that, everything is working fine. Now we want to see why system has selected M1 and not M2. So you can see a schedule tab or status tab below the run tab. Okay, click on the status. Yeah, statistical forecasting. Yes, click on the first one, yours business log. Yeah, click on this log and select one product 404464, product ID 404464. Yeah, click. Okay. See now, okay, this is system is giving for planning area this one, then product ID 404464. Okay. First substitute missing value, given. So this was applied. There was no missing value found in the points, okay, because all your quantities was actual. There was no missing value. If clicks his, he will find the missing values, okay, for the first product. Then the third thing that he did is corrected value for key figure, sales actuals, quantity saved in sales actual quantity, okay. Then step 1 and 2 forecasting steps, so and so, okay. Now for moving average 1, MAP is what 21.465. That means the forecasting error is 21%. Okay. For M2, forecasting error is 32%. Okay. That's why they have considered the lowest MAP value is 21.465. So system has considered M1. You're getting my point?
Yes.
Okay. So this is how a planner, needs to analyze the data. Actually, this is only for the understanding. We don't need to get into the details because system, if your key parameters, if your master data and your key parameters are perfectly well fed, then, everything will go fine. I will request you all, to create few more simulations of your own name because it's a test system. It is not going to impact anywhere. And then try and run this. Okay.
Thank
Thank
you.
Thank you so much. Bye bye.